just saw that the Hamiltonian restricted to, say, an irreducible invariant subspace U is just a multiple of the identity. Now, if this subspace is invariant but not necessarily irreducible, we cannot draw this conclusion. So let's say if gamma looks like this, maybe it's a direct sum of two or more different irreps. What then? Well, then Schur still tells us something about what the Hamiltonian looks like restricted to this subspace. So if you write this as a matrix, it will have this block form, diagonal blocks, maybe of different size. Let's say this is a d1 times d1, d1 the dimension of the representation gamma 1, and d2 times d2 block. And Schur 2 tells us that, let's do this in color, so Schur 2 tells us that these off-diagonal parts here are just zero matrices, rectangular, typically. And on the diagonal, of course, we have Schur 1, and Schur 1 tells us that, let's say here, it's a multiple of the identity, so that's a d1 times d1 unit matrix, and here it's a multiple of the identity. But in general, these two numbers E1 and E2, they would be different numbers, different energies, different eigenvalues of the Hamiltonian.